So since it's not a digital one, you don't have to put it back there. All right, and so go ahead and go to sensors and data collection, and you're going to go change that time to be 15 seconds instead of 10 seconds. Okay, hit OK. All right, so what we're going to do first is we're just going to kind of show how to find the reading, the force reading there. It's kind of jumping around all over the place. So go ahead and stand really still, and you're going to hit play. And then go ahead and hit stop. Okay, so how still were you standing?
Probably not very.
Okay, so go ahead and show the picture to everybody how still he was not standing.
Ooh, Seth, you better step it up, man. Look at that.
Okay, so what happens then is we're going to want the average of those. So go ahead and select that total region basically. So draw across, select it. Yep. I didn't actually select, so do it one more time.
No.
Okay. Oh, it's kind of jumping around.
Yeah.
Go ahead and grab the stylus and do it. Sometimes it works better with
Where's
the
the
stylus.
stylus? Is it here?
Yep. And I think too it's helpful if you hold it landscape. Yep.
So what exactly do I need on?
So you're just going to grab, hold, and drag
The
across.
entire thing?
Yeah, basically the entire thing. There you go. So now that it's selected it, we're going to do analyze. We're going to do statistics and choose the force. And what's the mean? Because that's the one we're interested in most.
787.3.
Okay, so 787.3 newtons is what your just standing weight is. Okay, so what we're going to do now is go ahead and what's going to happen is he's going to hit play, and then you're going to hit 2 pretty soon after. Okay, like within a second after. Okay. All right. So whenever you're ready.
Play.
Okay, so let's see what we have. Is that what y'all's graph looked like?
Oh, that's what Keegan's look like.
That's what Keegan's looked like. I did see one graph in the whole room that looked kind of like that, okay? So what is going on with that? Well, where was it that everybody else was wrong if Keegan was right on it?
Well, at least I didn't take into account the settling of it.
Yeah.
Like the start, when it starts, how your force goes down a lot more, and when it stops, how your force also goes.
So the part that was probably the most surprising is that middle portion, is that right?
We didn't.
I didn't expect it to go all the way back down to where it was. I expected it to be kind of higher than it was.
Okay, so why are these values here the same as these values over here?
Because the net force is zero.
Constant speed. Constant
Okay.
velocity.
Yeah.
But you guys were thinking that
Oh,
if you were
constantly
moving,
accelerating.
Yeah.
then there had to be a difference there, right, than what you had at the beginning.
Actually, I was just kind of thinking that would constantly accelerate all the way up.
Okay? And never have a
Yes.
constant velocity. So accelerate up and then accelerate
Back
with a
down.
negative acceleration.
Yes.
Okay? So that's something that I think that a lot of times surprises people, that is actually the same value. And that goes back to our balanced forces.
Yeah.
Okay, no acceleration. So our forces are balanced there. At the first part right here, what do you notice as far as the unbalancing of forces? Is there more force up or down on Seth? Why is it more force up?
Because it's changing from a standstill to moving up in a short period of time.
Okay, so what direction is the acceleration? Upward. So we would need more force up,
Yeah.
an unbalancing upward. Okay. What about this part right here where we're nearing the top?
It need to start heading back down so it stops.
Okay, so let me ask you something.
So
Like,
it'd have to accelerate downward, so yeah.
is it heading
Stop.
downward or is it accelerating
It's
downward?
accelerating downward, so it'll stop.
Okay, so
From
we're
not
still
supposed
moving
to.
upward though,
Yeah.
right?
Yeah.
Okay, so that would be an unbalance of forces there as well. Okay, all right. So what we're going to do is we're going to do the exact same thing.